Okay, if I just tab in here and just expand the script, you can see that I've got, this is the script where I pretty much left off at the end of doing my coverage projection demonstration. I want to use this as the starting place for a demonstration on how to execute a patch projection. Okay, so I think this will save a bit of time doing it this way. So the coverage projection had two projections. I did an orbit and I did a sky dome, and I'm actually just going to delete the sky dome one because I don't need that anymore. And what I'm going to do is I'm just going to take this bunch of nodes over here and I'm just going to copy them. So I can use that as a decent starting place. I won't keep the checkerboard because, or the projection camera, because I'll recreate those, but I will retain the merge map because I will be merging a patch over the top of this hero projection, so I will retain that and just disable it for now, and I'll also disable the project 3D node. Okay, I inadvertently created myself a viewer, and just to save any confusion with having more than one viewer in the scene, I'll just reconnect this up. Okay, so let's just scrub this in 2D view, so we can see what this is. This without this second projection, we can see that with this first projection that we had projecting from the first frame of the shot camera, we can see the shot camera coming round, but we can see the first projection camera there projecting onto this face of the sphere. So when we look at this in 2D view, we can see that as the projection camera reaches the extent by which it can see by which the image starts to run out. In other words, it can no longer, the projection surface is pretty much at its end now, and it's starting to smear. So we can see as this starts to come round, and kind of round about this sort of area here, maybe 88, somewhere like that, we can see that we're pretty much looking at this head on, and we can see the smearing starting to happen from round about this area to this real sort of extreme. So if this was a photographic image, we'd see a hell of a lot of smearing distortion in this particular area that we would definitely need to address. So I'm on frame 88, and I'm gonna regard that as the optimum position to create a patch. Okay, and that's for the reasons that I've just explained. Yeah, frame 88 looks good. So what I'm going to do then is I'm going to write out or render this as a still frame, and then I'm going to use that to patch over the top for demonstration purposes. So I'm going to come down to the bottom of our scanline renderer and type W to bring up a right node. I'm going to come to my project. You see I've already got a couple of files called smeared, which is what I've been using to test this. So I'm just going to name it smeared, and I'll append that with 88 because that's the frame that I'm projecting onto. Always good to it's always good because you may end up with lots and lots of patches in a project sort of sat in your image folder, and obviously you need to be able to differentiate them. So by putting 88 there, it gives me some idea about where this is used. Okay, so one of the things I definitely need to do here is I definitely need to write out the alpha channel, not just the RGB. The reason for that is that I'm actually going to be merging this image with a second image, which is going to be my patch. So I'm just using this as reference for my patch, and I'm going to need the alpha channels in order to be able to blend those two things together. Okay, so I'll render that now. I'll just set that to 88, so that's what we've regarded as our optimum frame, and that has now written out that particular file. So we have a still frame now, and we're going to use this now to perform our patch. Okay, so if I was doing this on for a real project, then this would obviously be part of a matte painting. So I wouldn't be bringing this in this particular state back into Nuke. What I'd be doing is taking this image into Photoshop, and I'd be then repairing this section of the matte painting using digital paint or photo bashing techniques, but whatever it took to basically repair that section, and then I'll be saving that out as a repaired image. But for the sake of this, I'm actually going to use a roto as my patch, so I'm just using this as reference. So we've actually broken out from the projection for now, because we're just going to actually use this as a test bed, and I think that'll be useful for demonstration purposes. And then once I know it works, then I'll connect it up to my projection. Okay, so as I said, I'm going to use a roto node. I need obviously an image to project that, so I'm going to come and get one of my new Checkmate images, and I'm just going to cycle through until I've got an image, a colour that differentiates it from the grey. Okay, so I'm going to now hit M to merge this. This is not a merge matte, this is a merge node, because we're working purely and simply in 2D at this stage. So what this is doing now is this is merging the Checkmate image, the blue checker pattern, over the top of the smear texture. And just to demonstrate that, if I hold down Shift X and type Shift X, you can see that by switching the stacking order of the render, the A over B, switching that around, you can see that those two images are merged together. Just that we can't see our smeared image at the moment because this is sat over the top. Okay, so I need to get control of this image in such a way which is going to allow me to blend it over the main projection. So by this, I'm actually going to use a roto node. So I'll just select my Checkmate image and type O, and that's going to bring a roto node into my project. And with this open, I'm just going to select the ellipse tool, and I'm just going to draw out an ellipse. It really doesn't matter too much about the shape of it because I'm going to adjust it a little bit later, but I'll try and center it as best I can. We do know that the majority of the area, the offending areas in this area, is in this region anyway. Okay, so we can see that our roto node is applied. We have a roto shape on here, but it's making absolutely no difference to our composite. In other words, it's not actually it's not actually working as a cookie cutter to take out this section of the image and reveal part of the smeared image below. Okay, so we need to address that. Okay, so this is basically involves some management of the alpha channel. I need to say that what I'm going to do here is a skill set that I regard as commonly held within the visual effects community, so it's certainly not part of my study, but I will explain it a little bit as we go along. Okay, so I've got my ellipse on, but it isn't cutting out. Okay, so let's just have a look through the channels. So that's what the red channel looks like, the green channel, the blue channel, and the alpha channel. And it's the alpha channel that gives it away. At the moment, this is pure white. Okay. Now the problem with this is that the way that the alpha channel works is areas that are white are registered as fully opaque, which means that they don't allow any transparency whatsoever. If this image is black, then it's fully transparent. So what we're looking to achieve here is we're looking for our circle and the inside part of our ellipse to be white, and then this area around the side to be black. Okay, and what this means is that we need to start by inverting our alpha channel. Okay, so I'm just going to come up above the roto node and type the invert. Okay, and what I'm going to do, but just before I move on, is just to simplify this. I'm just going to come to this side of this merge. So we're looking purely down this side. This side's sort of we're intervening before we actually get to this merge. So we're looking at this, and we can see that by putting in that invert node there, we've got the desired effect there with our alpha channel. However, there is a slight problem. If we look at our red channel, we can see that our red channel looks like this with the invert, but it looks like this without the invert. If we look at the green channel, it looks like this with the invert. It looks like that with the blue, without the invert. So effectively, what we've done by inverting is we've inverted the red, green, and blue as well as the alpha channel. So we don't want to do that. We only want to invert the alpha channel. So I'm just going to set that to invert just the alpha, and we can see now that's the red channel. And whether or not the invert is active or not, we can see it's not disrupted. But if we look at our alpha channel, we're back where we started. So this is essentially our desirable position. Okay. Now, if I now sort of connect into here, and we go back to our red, green and blue display. We can see some funky business going on in here, and this is basically a consequence of pixel math. We need to make sure that this stream is pre-multiplied, which basically means that the alpha channel is correct, the pixel math on the alpha channel is correct before it actually comes into contact with the second image at the junction of a merge. So we can now see that our patch is now correct. Now you can see that the actual position of the spline isn't quite correct. We've got some smearing down here and up here, but we'll deal with that shortly. We now know as a proof of concept that this patch works. Okay, so I'm going to now come back to my main composite. I can delete that right node, I don't need that anymore, and I can reinstate both my merge map node and my project 3D node, and I can connect this stream now directly to the project 3D, which was earlier it was my coverage, but now it's my patch, and we can see that it's on there at the moment, but it's and at the first frame it actually, you know, it just sits there in the middle. The reason for this is it's not yet projecting through a camera. So we need to come back to our frame 88, which is where we decided this was our optimum frame, and this is where we took our render from. So at this point I'm going to copy my shot camera and paste it, and then I'm just going to get my shot camera and call it projection camera, and again I'll append the name with 88 so that I know exactly what frame the projection camera was generated from. I'll recolor the node, and I'll right click and disable, or should I say kill, all of the animation from this. So I can now bring this up and project from this particular frame. So hopefully we've got something that resembles a patch projection. I'm just going to come back, this is going to cache a little, so it's not going to run at the optimum speed, but we can certainly see here that this is now patching over the offending areas. Now obviously the precision of the roto node now isn't quite right, but this is the benefit of doing this using software like Nuke, is because we can do this easily now, almost in real time, just by manipulating the roto node itself. So for example, if we come to frame 50, where we're sort of, maybe 45, where we're sort of starting to get sort of somewhere close to where the projection's starting to disintegrate, we can now get our roto node and we can start to extend, and we can see how this starts to extend our patch into, and also we can take the feathering, and we can start to use this to blend with the original texture. So hopefully you can see, I'm just going to pull that in a little bit because we don't have too much distortion there, but it's starting to distort at that point. I'm looking at this area, so we can start to then just create that blend with the original image at that point, and then manage the whole thing from there, and then use the feathering to just create a soft merge between the hero projection, which is coming from this camera, with the patch projection, which is coming from this camera. Okay, so hopefully you can see how easily it is to blend this patching with the main projection. Okay, so I'm going to conclude the demonstration here. Personally, I've found the experimentation required to produce this video really interesting and helpful. I hope you found my explanation okay.